All right. So the same way that the human brain can actually, the human brain not can, the human brain has uh, biological neurons, which means that we have certain neurons. We have um, more than 100 billion cells that are known as neurons. So these neurons uh, uh, have different functionalities in our brain. So you have, for example, what they call dendrite. But when we put it in an artificial way in terms of AI, we have what we call an input signal. So this is the neuron that will take all the input, all the information and input. So a neural networks in artificial intelligence will be a type of network that kind of imitates what the human brain does. So it's going to have an input, right? It's going to have an input layer, and then it's going to have other layers that will bring, um, which will also act in predicting whatever output we want to create. All right. So in an artificial neural network, we're going to have an input layer where we're going to have all the features from the data that we have. All right. And then we're going to have um, the weight. So this weight is how much of this information contributes to this object. And from there, we have a certain function that is created, or a certain result we have, and then we move to the next layer, and then in the end we have an activation function, and then we have an output. So for you to understand how each part of the neural network is going to act, let's say for example you want to create an AI tool to determine between to take pictures and pictures of numbers and tell you which number it's that. Okay, which number that's number represents. So what we're going to do as we're training this model, we're going to use maybe 1,000 pictures of numbers that were written by people with the handwriting, right? So when you look at that, each picture will have a certain size. So we have each pictures that will have, maybe we have a picture, this maybe a picture of the number. So each picture has a certain size. Maybe it's a 28 pixel by 28. 28 by 28, that is 784. So we have 784 pixels in total. And each part of the picture has a certain information. So if you write, when I look at this page here, which is a white page, so how does my brain know this place, this area is empty? Because my brain has understood the default of an empty space is white. So whenever it's white, it's going to give it a certain value. So it's gonna be 000. But once there's a color there, from the darkest to the lightest, it gives it a certain value, which the value will go from 0 to 1, right? So the inputs here will give us, out of all those 784 nodes that we're going to have in our input layer, each node will take the information of that small pixel. You understand? Of that small pixel that we had there. So we're going to have, let me see, does this allow me to, let me see if I have an option of, team is supposed to have that option. I wanted to see if guys, please make sure that you mute your mic, especially when you're joining the class. I'm trying to see if team does it have an option for a board? Let me see. Let me see. Yeah, I'm surprised it can't give me that option. Control, share screen. Yeah, but it's supposed to give me that option. Give you more options. Okay. Okay, unfortunately, it doesn't give me a board where I can be able to draw that. Okay, but I can explain it from here. It's okay. All right, so we basically, let's say, for example, the first input there, which is the corner of the picture, for example, give us an activation of 0.2 because it has a certain color. So from the darkest to the lightest, we have an activation there. So from that activation now, the second node as well. You see now, because we have 784 pixel in total, so each pixel will have a certain number. Now those numbers will be multiplied by the weight. Now this weight are what we call parameters. So they are created by the model itself. So all you can do as a developer is to determine the range in which they can be created. So the whole process of training a model is the model automatically changing this weight. So it take any value between 0 and 1, for example, if you keep it there. So it take that multiply by that. So it does all the mathematical calculation. So whatever will come from this x1, which is the first node, multiplied by the first weight, will give us the output in the second layer. So the calculation in the first layer multiplied by the weight give us the second layer, and then we have third layer until you get to a point where no matter how many layers you have, you will need to have an activation function. And in this case, an activation function, in the case where I told you we're trying to find if this number that was written is it's a 1, a 2, a 3, or so we have about 9 options, which is from 1 to 9. So looking at that issue there now, the activation function is going to tell me, based on this calculation, the highest probability of this number is that it can be a number 7, and that will be an output number 7. So that's how the neural network works. So it now, in a human brain, in your biological network in the mind, I gave you an example yesterday where I just said the word Cristiano. But because of the knowledge that you have, because of every information that you have, some of the people will tell me Cristiano is one of your friends, or some of the people can think of Cristiano Ronaldo because of the information that you have. So that's exactly what the brain does. The brain does exactly what the machine also does. All right, so that is how a neural network will work. So an artificial neural network is just an information processing system which is designed to imitate the structure and the function of the human brain. And this is exactly how models are trained. This is exactly what the model will do with the data. So it's take from the data, it's learned from the data in this type of neural network and get an output from there. All right. So when we're looking at the history of deep learning, we go back to the years 1956 when the whole idea of AI came into a certain meeting that was done by a few scientists. When they came in that meeting, they asked the question: can we make machine think? Can machine think? You understand? So Alan Turing is the one who came with the idea, and then there was what we call the Turing test, which has to test. They will take maybe a certain question, and then the machine will answer the question, and then they will ask a human being who answered this question. If the human can say it was a human who did it, that means the machine was able to fool a human, then we will say the machine has passed the Turing test. So the Turing test was all about seeing how the machine can fool a human being, right? So looking at the idea of deep learning, when machine learning started with artificial intelligence in 1957, the first thing that was proposed was the perceptron. The perceptron was just a neural network with just one layer. You know what I'm saying? And from that time, deep learning has grown to a point where in 2016, an AI was able to beat a human at a game called Go. The Go game is a game that is played a lot in Asia, you know. So Lee Sedol, who was the world champion of Go, was beaten by a machine, and the score was about 4-1. So that was one of the best innovation of artificial intelligence, because it has proven now that computers are stronger than humans. So you have as I mentioned that before, that when you look in the year 2009, when we have been able to develop highest level of GPUs, right? And in terms of computing power, there's now high level of GPUs that are being used now to train neural networks. And this is the reason why, when you look from the year 2009, of companies such as Facebook, YouTube, and many of these social media, because they are powered by AI. So this is the reason why nowadays we have high level of technology, such as in 2022, when OpenAI, which is ChatGPT. So ChatGPT was trained. The first version in 2022 was trained based on millions of books. So they take the millions of books and give the information to the AI and let the AI learn from those information and be able to predict. So and then in 2000 and then ChatGPT has been moving forward. So today they are already on the GPT-5, and so these models are learning every time. They're learning from new information on the internet. Nowadays, ChatGPT can, when you ask a question, it can browse the internet and find an answer. But to show you that everything that you're getting is trained information. It has learned from it. It does not invent anything. This is the reason why sometimes I've got there was a day, I'm not sure if it was ChatGPT or DeepSeek, where I told ChatGPT or DeepSeek, I can't remember properly, or I think maybe. No, it was ChatGPT or DeepSeek. I'm not too sure, but this is the story. I had a client of mine that asked me to design a certain app for them, and it was done. But then the client promised to pay on a certain date, but they did not make the payment. So I asked DeepSeek or ChatGPT to write for me. I told ChatGPT the story. I gave them the email that the client sent to me, and I asked ChatGPT to write an email to check with the client and find out and everything. And I told ChatGPT. Now ChatGPT was able to read in the email I gave, to read the date, and ChatGPT respond to me, or if it's not ChatGPT, DeepSeek, respond to me by saying the date hasn't passed yet, while the date has passed. So the AI tool was not able to pick up that the date has passed already. Why? Because it was trained with historical data. You understand? So that's why some AI tools do not know automatically, unless they have the ability to browse the internet. They do not know automatically what's the date today. That's why when you asking these tools to write for you an email or write for you something, you must check the dates in those information. This is why sometimes these AI tools can give you the wrong information because maybe a certain research was done after the date when this AI was recently trained. You understand? So this is why you find, for example, ChatGPT. If you are using ChatGPT, the free version of ChatGPT, you will be using maybe GPT 3.5. Or nowadays, they will give you access to GPT-4 for, I think, an hour or something like that. And then they will tell you you can only come back after 2 hours, or else it downgrades you to 3.5. Why does it downgrade you? What's the difference? The difference is the quality of information it gives you. So it's going to give you old information. It may not be updated. So that's why AI can give you the wrong information, because it was trained with previous research, previous information. And if you are dealing in an area where information are new, every time they're creating new information, that is going to be a problem, because now you will have to update your information. That's the same way as human being. I can tell you a story today, and then after a year, I come back and tell you a different story, because at the time when I told you the story, maybe I did not have enough information. That's exactly what AI does. So AI is not always 100% right, because it has to learn from new information and update itself. So when creating this model here with the perceptron was just a simple neural network with just one input layer, one output, and just one operation happening there. So it's take from maybe the final answer to this will be to classify maybe a binary classification. The binary classification can be an issue of maybe determining between male and female, yes or no. In the case where we mentioned last time that we can use an AI to take people's, maybe you take someone's weight and determine if this person is healthy or unhealthy. So when we look at that, that's how simple the perceptron was. So the perceptron was just a sum of this. So x1 times w1 plus x2 times w2 plus x3 times w3. That will give us the final prediction. This was a single layer perceptron. All right. So now the perceptron was not able to solve some of the issues, such as what we call the XOR, which is the exclusive OR. The exclusive OR, which means that we need to have one of the input, which is like the two inputs must be opposite. So if one is a 1, the other one must be a 0. If the other is a 0, the other one must be 1. So if the two inputs are different, then the output will be positive. But if they are similar, the output will be negative. But now the perceptron was not able to solve an XOR problem. That's how there have been a birth of other type of neural network, and neural network has been growing from that time. All right. So as neural network are growing, we look at a fully connected neural network. Fully connected neural network means that we have a neural network where each input is connected to each node of the following layer. All right, so these are the most powerful way of training neural networks. So this has created the most powerful way of training neural networks. So we get to a point where, let's say in this case, okay, so in this case we have 3 inputs. So the 3 inputs are what yesterday we call the features. All right. So these are the features. So the first input layer will have all the features. So we have all the features, and then we have the hidden layers. Remember, guys, the hidden layers, the numbers of hidden layers will determine on the developer themselves, right? Based on your knowledge, based on how you can do your proper research, you will know how many hidden layers you have to create. But the input layer is the most important, because the input layer needs to determine the numbers of features, and the output layer will determine the number of output. What is the output of this AI? What is the output? What are you trying to predict? All right. So we look at this case. So the input layer give us 3 nodes. So we need just 3 information. These are the 3 features that we have. Yesterday we mentioned the case where we want to see if a person is healthy or unhealthy, right? Is this person healthy or unhealthy? Based on what? We look at the weight, the height of the person, and what else did we talk about? Did we say we look at? What's the third one? Does anyone remember? Is there anyone who remember? Does anyone remember the 3 features we said we can take from that scenario? Guys, are you still with me? Are you guys lost? If anyone is lost, please, you can tell us you are lost, or forever hold your peace. Is anybody lost? Are we still on the same page, guys? Are we still on the same page? All right, perfect. Thank you for the time. Okay, guys. So remember yesterday we said let's say we want to create a system which will determine if a person is healthy. Based on what? Based on which feature? We're going to look at the weight of the person. We're looking at the age of the person, and then we look at the height of the person. So those are input features. So node 1 will have that information. How old is the person? 16. What's the weight of the person? 60. And then X3 will be what? What's the age? What's the what do we say? The height of the person. So those are features. Now, what the machine is going to do? Now we provide how many what you call that? How many data we have? Maybe we have data of 1,000 people. Each one, this person, this was the weight, this was the height of the person, and this was the age. And that person was labeled as an healthy person. The other one was labeled as unhealthy. So now what we're going to do, we take those data, we now put it in the neural network. So each sample, the first sample of a certain person, it's going to go into these neural networks. Because remember now here, what the neural network is going to do is it take that information, place it in the neural network, and this weight here, these connections are numbers that will keep changing. They will keep changing. So these numbers will keep changing. As they are changing, they get to a point where they give us a final number. All right. So they give us a final number, which will determine if the person is healthy or not healthy. That is the output layer. So there will be a calculation here, which will try and match what we have here. So sample 2 does the same thing. Sample 3 does the same thing. So the calculation here for us to get the new value in the new node here. Remember, only the input layer will have information in the beginning, which will be picked up from the features. Now from that information here, multiply by the weight, we will have a certain value. This one. The information in the second node, multiply by the connection here, weight 2, we will have this. And then the third one, same thing. Connection with the first here. And then we will add a small value that we're going to call a bias. So to get the information in this node, we have all these values. Then it gives us this node. To get the information in the second one, we do the same thing. This one. This one with the connection with that one, with W2. W3. You understand the connection with that one? We get the Z2, Z3, Z4. And now from this, we do the same process. We're not doing it, it's the machine that is going to be doing it. So the machine is going to do this process. This is why if you're training a model on your laptop, you will notice that the temperature of your laptop is increasing. Why? Because your GPU is working. There is a lot of calculation, mathematical calculation happening here. The process will be really advanced to a point where it's now using your GPU. This is the reason why it costs to build all these big AI such as ChatGPT, and then because there's a lot of operation that are happening in training this type of models. All right, so this is a fully connected neural network. That's how a neural network will work. So basically, the functions of a single neuron are simple, and many neurons need to work together to perform a complex task. So an artificial neural network is just a computational model inspired by the biological neural networks. So this is how things are going to happen. So the more hidden layers we have, the more we can have the ability to understand the data. But sometimes you can't have so many neural networks because the AI is getting lost. And remember, we spoke about the issue of overfitting and underfitting. So do not make your system overfitted because you have so many layers. Right. So the numbers of layers, there is many ways of really calculating what type of, how many layers you should have and everything like that. So it's very important, right? So the hidden layers will have multiples abilities, right? They will have the ability to represent features. So the features in the hidden layers are represented based on the calculations that are going to happen. And in the final layer will have an activation function. An activation function is a function that will take whatever results came from the whole neural network and manage that result in a certain range in order for you to get the output. An example I can give you is this. We wanted to see if the person is healthy or unhealthy. So we can determine in all the calculation that we're going to have, we're going to get a value that we're going to range that value between between 0 and 1. And if that value is bigger than 0.5, it means the person is healthy. If the value is less than 0.5, the person is unhealthy. And what is going to make sure that every value that comes is ranged in between 0 and 1 is an activation function. Which means that after all those calculations, if maybe the answer comes as 6.2, the activation function will take that value, convert it into a value between 0 and 1. And that's how we're going to have our output. You understand? So whenever you see an AI that needs to, you look at your phone, your facial expression, your facial, like I'm looking at my phone now. If I look at the phone, it can unlock the screen. So what the phone is doing is it's taking an image of my face and quickly does an AI calculation and see the probability of this person who I am being compared to the data that are provided when I bought the phone. So when you buy your phone and then you scan your face for the first time, it saves those data. The phone knows how you look like. This is why you can cut your hair, you can keep your hair, your phone still unlocked, because it's a probability. There is a certain range. So the final number will be a probability. Maybe there's an 80% probability that this is you, then it's gonna open. If the probability is less than 80%, it's not gonna open. So that is a binary classification. So we have unlock or do not unlock. Unlock if all the calculations are done and then it gives me an answer of 0.8 and above, then it's need to unlock. If it's below 0.8, it mustn't unlock the phone. This is why you will take your phone. Sometimes you are in a certain angle or there's not enough lighting. It doesn't unlock because of the probability that was set there. All right. So there's many activation functions. We have like sigmoid function, softmax, RealU, soft sign. So there is many activation function depending on what you're working on. You have, for example, the RealU, which is an activation function that will be used especially in between the layers. So when you go from one layer, you do the calculation to get to the next layer. Instead of letting the values grow, you can already use this activation function to reduce the values to a certain small value. And the best activation function that is used in between layers is the RealU. Okay. So, and then you have in the last layer, you have activation functions such as the softmax function, which is used especially in the cases where you have classification problems, where you want to see between certain classes, you have the softmax function. All right. So these activation functions are very, very important. So the choice of the activation function is very important, guys. All right. So I think that would be all for today. And next week, we're going to talk about what the choices of activation function and what the activation function do. For example, you have the sigmoid. This is the formula of the sigmoid function. So the sigmoid function will take any value and convert it to a value between 0 and 1. All right. But the sigmoid will have a problem. The more layers you have, the more it's losing the information. We call them a gradient vanishing problem. This is why you should use the RealU function, activation function. All right, guys.
Then
yes.
where does a gradient falls?
Where does the gradient goes? Okay, all right. So
yeah, the gradient function is what?
Yes.
Yeah, that curve.
When we talk about the gradients, this is what we mean. You see, when you are training a model, right? So let me go to a neural network. So when you are training the network, this is what's happening. Remember, you had a value here. Remember what I told you? The age 16, let's say 16 was a feature, right? This 16 need to multiply by the weight that the machine is going to be creating here. So that weight can be 0.1 or 0.2. So if you multiply 16 by 0.2, 16 multiplied by 0.2, that will give you 3.2. Can you see that value has reduced? We went from 16 to 3.2. Plus whatever calculation is going to be done, Maybe the value here in this node, we went from 16, now in this node we have a 3.2. So the more layers we have, can you see that value is being reduced? Based also on the activation function, because the activation function will convert this, whatever happened here, into a smaller value. So the sigmoid take a value, convert it into a value between 0 and 1. So that can be 0 point something. Then when we're moving, the more we're moving, the more that value is really reducing. That's how we're losing that value. That's why we call it a gradient vanishing. You understand? That's how we lose the value. And then we end up start doing calculation with the wrong values, and the whole AI become like become inaccurate. But now, yes, now when you look at the ReLU, what the ReLU does is for every positive value, it's gonna convert it into 1. So as long as you have positive values, as long as you have values, the ReLU is gonna be making it 1, 1, 1, and that will help that the model is still alive as you're moving through the layers. But as we move with activation functions, you will understand it more. You will understand it better.
Yeah, no problems.
All right, guys. That's all for today. I'm just gonna stop the recording, and for those who can turn on the cameras, please do, for us to take an attendance screenshot.